Alright, here's a second example from section 8.3. This one's also going to be a data set um, that we're looking at. We're looking at number 16, and in number 16 we're dealing with earthquakes. And so they give us the data here in number 16 about earthquake depths. And so we're going to test a claim. So we're going to look for that claim and realize our claim is in the last little bit, that these earthquakes come from a population mean equal to 5. And so we'll set that as our claim. Our null hypothesis is actually going to be the same thing. And our alternate hypothesis can't be the same thing because it has a straight equal to, so it's the not equal to situation like we've seen in the past. So what are we going to do here? Well, we're going to go find our test statistic by taking the sample mean, subtract away the population mean, dividing by S all over root n. And so let's go get those numbers. According to the summary statistics, x bar is equal to 5.82. The mean is, the population mean comes from the statement of the null hypothesis, and that's 5. And we're going to divide that by S divided by the square root of n. All the numbers given to us. That's the way it's going to feel like in every problem. So we're going to take our 5.82, subtract away the 5, hit equals, divide by, open parenthesis, 4.93 divided by the square root of 600, close parenthesis, and we come up with a pretty big t-value, 4.074. And that does match what they're having in the back of the book, so we feel really good. Now, this, since it's a not equal to, the alternate hypothesis can be true in both directions, and so it's a two-tailed test. Our significance level is 0.01 again, and double checking that, that's exactly what they have. But now that there's two, remember we have to split it up. If I draw a picture, now this is 0.005 in one tail, or 0.01 in two tails. So remember that 0.01 just got split up into two tails. Our degree of freedom is n minus 1, so it's 600 minus 1, or 599. Let's go see what we have in our t-chart. So let's go back to our t-chart, look that up together, and so tap on that so it becomes big, and we'll slide down. Hopefully it will let me just slide on down. I get stuck every once in a while. Let's first look for our degree of freedom. Our degree of freedom was 599. I apologize. It was 600 was the n. 599. So I got to go to the closest one. We're definitely closer to the 500 level. So 500 will be our guy. Let me get rid of this mark right here from earlier. But at 599, we're definitely closer to 500 than we are 1000. So we're going to go to that row. And remember what we had. We had 0.01 in two tails, right? 0.01 in two tails. Well, that's this very first column right here. The one right here. 0.01 in two tails. Now notice 0.01 in two tails has 0.005 in each one of the tails. They're linked. And so we're getting our number out of that first column. Where do we travel on down? To the 500th row. And we get our value straight out of that. And so we're getting a 2.586. So the back of the book will reflect that critical value, doing it the traditional method way. So 2.586 should be what we go and use. So as we go to number 16, we have this as negative 2.586, and this is positive 2.586. So if our t-value is more than 2.586, either positive or negative, we're going to reject, and it certainly is. It's coming in at 4. So we're going to reject the null hypothesis. Perfect. I don't even need to look above. I know how I'm going to start this. There is sufficient evidence to support, right? Every time we reject, Um, well, actually, let's look at this situation. So I chose it. I was going to write to support the claim. But let's go look at the claim. What did we end up supporting? We ended up rejecting the null hypothesis and supporting the alternate. So in the previous example, the alternate was the same as the claim, but right now the alternate is opposite. So often when this happens, when the claim and the null hypothesis, let me actually refocus that. In this case, maybe it's better to realize that, and I'll come in with the highlighter, that the claim and the null hypothesis are the same. So that when we reject the the null hypothesis, we're also rejecting our claim. And so they will probably change this, and let me just double check. Yep, that's what they'll do. They're going to change this, and I'll draw attention to it by writing it in red. They're going to change this to not support the claim. They're going to change it to these words: when the claim and the null hypothesis are the same. Now that'll only happen with the equal to symbol. There is sufficient evidence to warrant rejection. Right? That's going to be our change of words. Of the claim that the mean of the population is equal to 5. So in this case, the best we could do was reject that claim because the claim was stated in a null hypothesis format. And therefore, when we rejected the null hypothesis, we rejected the claim. Our claim is actually shown to be wrong. And so we have just warranted the rejection of the claim with sufficient evidence. So pretty powerful. And so I changed it up a little bit from how the wording was in the claim, but as long as it's essentially saying the same thing as what the claim is, you're good. So typically when we reject, we have sufficient evidence to support the claim because the claim is in the alternative hypothesis format. But in this case, because it was the same as the null hypothesis, we're going to warrant rejection of that claim. So pretty interesting.